All right, good evening, everyone. I hope my voice is clearly audible. You can simply raise your hands to confirm this. All right. All right, guys. So we are waiting for a few more candidates to join in, right? So meanwhile, if any one of you have any doubts, you can ask in the chat section. Right, I'll be addressing your doubts one by one. Right. So any doubt related to what we discussed yesterday, right, about the moments, if you have any queries, any doubts, you're free to ask in the chat section. Right. Meanwhile, we'll wait for others to join in. And once everyone joins in, we'll proceed ahead with the discussion. Right. And if you're able to understand what we discussed yesterday about moments, you can simply put a yes into the chat section so that I get to know. And if you're not able to understand, you simply put a no into the chat section, right? So this way I'll have this voting, right? How many of you are able to understand and follow up with the session? Right, so yes, today is our last class on statistics. This is basic statistics, right? You'll learn advanced statistics in your machine learning. Right, so okay, so those who of you are putting no in the chat section, you do let me know exactly what you did not understand, right? Because let's say moments is one of the simplest topics, right, in statistics, right? So if you are putting a no into the chat section, you do let me know what you are not able to understand, right? So this way I'll be able to address your doubt very precisely. Right, and if someone is not able to understand everything in moment, right, so you just need to go through the session at least 1-2 more times, right, so that you get an insight of the like what exactly are moments and why do you actually calculate them. All right, so the summary of the moments is already discussed in yesterday's session. I'll just show you the summary part where I summarized all the moments here. Right, so these are the formulas, those are used, and based on the case study and based on your problem statement that you're working on, right, you'll use the relevant formula. All right, so I've derived these formulas in the live session itself. Right, so you'll be able to understand how these formulas have been, like how these formulas came up. All right, and these formulas are, you don't need to remember these formulas or, right, because nobody is going to ask you. Just have to understand what exactly is the intuition behind moments. Right, so these are basically the intuition that we have discussed. Right, so basically what do they represent is the intuition here. All right, so for example, let's say mean basically represents the average value of the data, right? At the same time, variance tells you about the spread of the data, how your data is actually spread along the number line, right, or along the coordinate axis. All right, and next is skewness. Skewness basically tells you about the biasness, basically, which particular value is trying to dominate the it's trying to dominate the target variable or trying to dominate the predictions, right? And at the same time, kurtosis tells you about the peakedness, how much peak your distribution of data has. All right, so these are the insights that you can learn from moments, right? And will, of course, walk you through the practical implementation of these moments, where they are exactly used and what is their exact use in the machine learning process, or let's say data analysis. Right, so everything in data or analysis of the data is purely game of statistics. You'll let's say you'll work on one or the other statistical methods while analysis of the data, right? Because it is data science, will be using scientific methods on the data set that we are working on, and eventually we'll be able to extract the information from the data, right? So you have to understand the algorithms first, right? Or the how statistics work. You have to understand this, and then only you'll be able to apply it and extract the information. All right, so I've already informed moments are used for the analysis of the data to understand your data in a better way. All right, and basically I've also walked you through that in every tool that you'll be using, be it Python or be it Pandas, NumPy, SciPy or Excel, right? There are already inbuilt formulas for these. You don't have to write the formulas from scratch, right? If you wish to, you can, of course, write these formulas from scratch. This will help you to practice the how basically formulas are constructed in Excel, right? So yes, this is one way of learning. All right, so yes, those who are saying no, can you please put down what exactly you are not able to understand so that I'll be able to elaborate the same. Right. So since we have only discussed what moments are, if you have any doubt until here, what exactly moments are, you can ask your doubts. If you have any, let's say, doubts related to where these will be used, so we haven't discussed that yet, right? And I've already informed you that the practical implementation of these will directly be used in data analysis with Python. So when you'll be learning Python, all these topics will not be covered, the theoretical part, right? Only the implementation will be covered because theoretical part and the intuition is being covered here, right? So you need to take this knowledge when you'll be learning Python, right? So this will eventually help you to perform the analysis on the data very efficiently. All right, guys, so let's wait for 5 more minutes and then we'll proceed ahead with the further discussions, right? So meanwhile, if if you have any doubts, you can ask in the chat section. Right, so this I've already informed everyone that this is one of the easiest topics in statistics, right? All of the topics that you learn in advanced Excel are more complex, right? So you need to you basically need to gain an understanding how you can understand and grab the complex topics of statistics and machine learning, right? So this will eventually help you in understanding all the advanced statistics and machine learning. All right, so XIs here are basically it's just a form of representation, right? This XI, this XI or this XI everywhere. This is just the form of representation. These basically represent the elements of your these basically represents the element of your data, right? So for example, the data set we were working on, well, it's 14, 14, 17, and 18, right? Okay, let me take a different color. All right, so this is the data set we were working on, right? And this data set here, let's say this is your x1, this is your x2, this is your x3, x4, and x5, right? So collectively, these are represented as xi's. So where you can replace the value of I from 1 to n. This is exactly what this summation represents, right? Summation basically is you put values one by one and then add all of these together, right? So summation of xi from I equals to 1 to n, basically this can, if you expand this for this particular data set, this will be expanded as x1 plus x2 plus x3 plus x4 plus x5, like this. All right. So this is how it will be expanded. This is the expanded form of summation of xi. Right. So here xi is basically in generalized terms. This is how mathematically it's written. Right. So everywhere in mathematics, wherever mathematics is involved, right, you'll see one or the other kind of representation. For example, mu. Mu is basically just a representation. You can write mu by any other term as well, right? So maybe if you want to write mu as a, that is completely okay, right? You just have to understand the intuition of this, what exactly this is representing. So this is the let's say it's the general convention that we usually follow, right? Mu basically represents the mean of your, it represents mean of your population, right? Whereas X bar basically represents mean of your samples. All right, so this is just a convention that is used. You'll see these kind of representations very frequently when you learn machine learning, right? This kind of representation is just for representing the concepts on pen and paper. All right, so this is how these are just the representations, right? Okay, one of you is asking, how do you create 25 data points in second moment? So basically, you can pick any 25 points, right? I already gave you this as homework, right? You simply create 5 random points, random data points. Simply take any number, right? The count should be 25. Like how here the count is 5, right? N is equals to 5 here. So this count should be 25 if you want to work on the data set of size 25, right? You can create any random number. All right, so simply take any random number, maybe some 3, 5, 7, 2, 8, 5, some any random numbers, right? Simply take 25 numbers, right? And then you can simply add all of these together, divided by 25, you'll get the mean of the data, right? In a similar way, if you take the square of every term and then add all of these together, and then divided by the total number of elements, you'll eventually get the variance of the data, right? So this is how it's done. All right, you can basically calculate the centered variance as well. Simply subtract every value from the mean of the data and then take the square, right? So this purely depends, how you want to calculate. All right, so 25 data points can be any random values. All right, so what are the functions of these moments in Excel? We are going to discuss that only today, right? You just need to have patience. As I've already told you that will see the implementation of this in Excel. All right, so let's proceed ahead with the discussions. Let me share my Excel sheet and then. All right, so this is the original data set that we were working on, right? This is your basically sample employee data set that I've shared with you on GitHub link, right? So you can access this particular data. And as I've already informed in yesterday's session, all the moments can only be calculated purely on the numerical data, right? And numerical, that too continuous, right? So let's say here, if I want to calculate the moments, let me All right, so this is the data set that we were working on. Let me remove the first column. All right, so I'll select all the data set. Okay, so I'll basically remove this particular column as well because it was not originally the part of the data, right? So this is the original data set. Simply select all the data, right, and press Control and T. So this will basically format your data as tables. So as of now, you cannot see all these sorting and searching signs, right, in the column. So I'll simply format it as tables, and now all right, so it's taking time, right? Because I believe all the cells and rows and columns have been selected, right? So let it take its time, right? So this will basically format your complete data set as tables. Right, so this is your data set. Let me select all the columns. Right, so this is your original data set. We'll simply format it as table, right? So that I'll get all these sortings here, right? So once this is done, right? So what we'll do is we'll simply calculate the moments. Let's calculate the mean of the data. All right. So let's do this. Let's calculate mean, then we'll calculate the variance, followed by standard deviation, right? Followed by skewness, and finally followed by the kurtosis of the data. All right, so we'll do this on two columns. First will be my salary column, right? Second will be, let's say, my age column. And finally, I'll also perform the same on the height column. All right, so these are the only, let's say, data that is continuous in nature, right? So how we can calculate the mean is basically we can use the average function, right? So average will basically give you the mean of the data set. So let's find out the average salary of an employee in this organization, right? So the average salary is $113,217.4 yearly, right? This is per annum. Followed by, let's say, the variance. Let's find the variance, and we can directly use the formula for variance. And here VAR dot P will basically calculate the variance for the entire population. All right. And VAR dot S will calculate the variance for samples. All right. So since we want to calculate this on samples, we'll simply use the VAR dot S. All right. So this is the variance that will be calculated on these salary column, considering it as samples. Right. So if I calculate the variance, this is the variance, which is a very high number, right? And this number is very high because there are a lot number of unique data points, right? When you have very high number of unique data points, the variance will be very large because there is one or the other difference between every two values, right? Which is why the variance is very high, right? If we calculate the standard deviation, right? So standard deviation again can be calculated on population and samples. So let's calculate it on samples, right? Again, I'll pass my complete salary column. So this is how the standard deviation of the sample can be calculated. So this is nothing but it is the square root of this value, right? If you, let's say if you want to verify this, you can simply take the square root. Let's say I'll simply use the power function, right? And in power function, I'll pass this as the number and the power will be 0.5. All right, so this is exactly what we are getting here, right? These two values are exactly same, right? This is nothing but square root of standard deviation is a square root of variance, right? So the difference between population and sample, I've already explained this in yesterday's session, right? So if you consider any given data set as your population, this basically means that it is the complete data set in itself. So basically you cannot add or remove values from that particular data, right? And for if you consider it as samples, so you can basically add or remove or update the data as and when required. All right, so this is basic difference between population and samples. All right, so the detailed difference between population and sample, again, this will be covered in your uh, data analysis with Python, because that is the area where the actual meaning of population and samples can be understood. All right. Right. So if you calculate the same value on population, okay, let me insert a value here, insert a column, right? So here we are calculating this on, let me just edit this, right? This is on population, right? And here we'll calculate the salary column considering it as a sample, right? So basically, if you can easily find out the difference between the sample and population based on the output that you'll get. All right. So for sample, the average will remain same, right? Because there is no basically there is no concept of population and sample for average. All right, or mean of the data. So this will remain as it is. Right, followed by, let's say if you want to calculate this on, okay, so this is basically this is sample as we have already calculated, right? And this is for population. All right, so let's calculate the same on considering it as population, right? So if I pass my complete salary column, this is the output that I am getting. And there is, of course, the difference of values, right? This value is higher and this value is lower, right? If you, let's say, if you want to find which of these is higher, you can simply use the max function here, right? And you can pass this value followed by this value. It will tell you which value is maximum, right? So this value is maximum. This is higher value, which means the denominator is lower in case of samples. As we have already discussed the sampling adjustments, right? N-1 in the denominator and N in the denominator. This is the only difference that we are getting here. Right? In the similar way, you can find the standard deviation as well using for considering your data set as population, right? If you pass your salary column here, again, there's a difference between these two, this value and this value, right? This value is comparatively lower than this value, which means the standard deviation and variance of population is lower than the standard deviation of samples. This is because of the denominator or the sampling adjustment that we have already done. Right. So variance basically, one of you is asking why variance came up to be so high. This is because of, if you see the variance, the formula for variance, you basically what you're exactly doing is you're calculating the square of the numbers, right? So assume you're taking square of these numbers. This is already a 6-digit number. If you take the square of this number, this will grow for more number of digits, right? This is already a 6-digit figure. If you take square of this number, this will basically go up to at least 12 digits, or if not 12, then 10 or 11 digits, right? And then if you add up all of those together, you'll eventually get a very high value, right? And doing the same for every individual value. Let's say you take square of the other number, square of the other number, and so on. You'll take square of every number, and then you add all of them together. So eventually you'll get a very high variance, right? And the variance, the reason for variance being high is there are a lot of unique values. Unique values are very high. Right? The unique values are high, which is why the variance is very high. Right? It has nothing to do with the minimum or maximum value of in the salary column, because eventually we are taking square of the numbers. Right? Now, moving ahead, and there is no concept of standardization. No standardization. There's no concept of standardization in variance. If you remember, there's no concept of standardization. Right? Because in while doing the standardization, what we do is we divide the value with the standard deviation, right? And when the standard deviation is itself calculated from variance, how you can, let's say, divide it by the standard deviation itself, right? You'll eventually end up getting 1, right? So, which is, there's no concept of standardization in case of variance, right? Like how there is no concept of centralizing the mean, right? We calculated the centered mean. Remember, we calculated the centered variance. We calculated the centered, let's say, skewness, right? And we also calculated the centered kurtosis, right? But we did not calculate the centered mean. We did not calculate centered mean. Why? Because while calculating the centered variance, we are subtracting every individual element from the mean of the data itself, right? If I do the same on the mean, right, while calculating the mean, if I subtract every value with mean itself, I'll end up getting 0, right? Which is why there's no concept of centering the data while calculating the mean, and there's no concept of standardization while calculating the variance and standard deviation. All right. So this is one of the major reasons why you're getting variance so high. Other values, the kurtosis and skewness, you'll not get as high value as you're getting in variance, because we have already applied the concept of standardization, right? Standardization, basically what it does is it will shift your mean to 0, and it will shift your standard deviation to 1, right? You'll learn about this in your data analysis, right? What is the concept of standardization, what it actually does to the data set, right? It will shift your mean to 0. Until now, what we have been doing is, in centering the data, we have shifted our origin to the mean of the data. But the concept of standardization, what it does is, it will shift your mean to 0, right? And it will, accordingly, it will scale every other value of the data, right? So it's very interesting concept, the concept of standardization, right? You learn this in your data analysis. What exactly is the concept of standardization, and it is applied almost in every data set that you'll be working on. All right, so let's proceed ahead. Now, next is the skewness. Again, skewness can be calculated using the formula of SKEW, right? So SKEW is the name of the formula, and it will basically tell you about the degree of symmetry and degree of asymmetry, right? So if I pass my complete salary column again, right, this is the output that I'm getting, 0.88. At the same time, let's say if I do the same for population, right? So let's pass and let's see. So you can see the difference in values, right? There's a difference in value. This is higher value, right? This is because of the sampling adjustment. In skewness, the sampling adjustment is n by n minus 2 into n minus 1, right? This is the sampling adjustment in case of skewness, right? Same goes for kurtosis. If you want to calculate the kurtosis, you can do the same using KURT function, right? And it will return you the kurtosis of the given data, right? Again, you can pass the salary column, and this is the kurtosis, which is negative of 0.043, right? Skewness also, you can get a negative value, all right? And sign only indicates the direction, right? We must be assuming when we are taking the fourth order of every value, why we are getting a negative value, right? The fourth order of any value should be positive, but negative sign is only showing you the direction. All right, so there's no, it's basically kurtosis is calculated for the sampling adjustments only, or along with the sampling adjustments only, which is why there's no formula for populations, especially, right? So we'll basically end up getting the same values for kurtosis. All right, the same can be applied on age. So if I want to apply, I'll simply use the average function. I'll pass in my age column, right? This is the average age of an employee in the organization, which is 44.3, right? So you can round this off to 44. All right, same can be done on variance. We can simply calculate the variance for considering it as samples, right? If you see, the variation of the age is also very high, right? 126.66. This is quite high as compared to the range of the data, right? Same goes with standard deviation. I'll simply calculate the standard deviation for samples. I'll pass in my age column here, right? And this is again the square root of 126.66. All right, same goes for skewness. I'll simply calculate the skewness by passing in the age column. And this is the skewness that I'm getting, right? This is very close to 0. So this data is almost normally distributed. If you see the distribution of this data, right? If we plot here, let's say histograms, right? You'll see almost the data is normally distributed, right? Although there are some variations, which is why it is not exactly equals to 0. But yes, the data is almost normally distributed, right? So this is how you'll get the output. And finally, we can also calculate the kurtosis of the age column, right? This tells you about the peakedness. Again, it is in negative 1.075. So yes, this is the output, right? The same can be done on height. Let's say average height that any employee has got. So let's see the average hike any employee has got. So 0.08% is the average hike, because most of the employees have got 0% hike, right? Same goes, let's say if you try to calculate the variance on the hike column, you'll end up getting 0.01. Very less variance, right? Because the number of unique values is very less. Almost 60, 70 or 80% of the employees have got 0% hike, right? Same goes with standard deviation. You can simply use it for samples, pass your hike column, right? This is the standard deviation, and this is square root of 0.139. Sorry, 0.0139, right? So this is the square root here. Next is, you can also calculate skewness by simply using the skew function on the hike column, right? This is the amount of skewness your hike column has. It is not at all normally distributed. So if you see the distribution of your hike column, right? Let's say if I go to insert, I'll go to histograms again, right? So you can see this is highly skewed. It's skewed towards the left, right? So lower values, this is the, basically this is the representation of 0%. All the employees who have got 0% hike, this is the representation of that, right? And there are almost 550 employees who have got 0% hike, right? Or 0 to 4% of hike, right? So this is one of the reasons of very high skewness, right? So let's calculate the kurtosis as well. Calculating the same on salary, the hike column, right? You'll end up getting 0.699. So this is the kurtosis. Right, so this is how you can easily calculate. Don't have to implement any of, or you don't have to implement any of the mathematical formula here, right? The formulas are already embedded uh, into the Excel formulas itself, right? You can simply go through the official documentation if you have any queries, right? If you want to know more about formulas, you can simply go through the official documentation of these formulas, right? So we are basically using the statistical formula, right? Which is average, right? And then we have used basically skewness kurtosis, right? So if you see here, right, inside the formulas tab, you have this more function, and inside this you have statistical functions, right? So these are the statistical functions. We have used kurtosis. This is kurtosis, right? You can simply, let's say, click on tell me more. So you'll get a detailed overview of this, right? What this function is and how it can be used. So you can simply expand the, or let's say if I want to work on statistical functions, right? These are the functions, right? So what does the average function does? It will simply return you the average of its given argument. If you click on here, it will give you more detailed overview of this particular function, right? This is from the official documentation itself. You can read about this formula. What is the syntax, how this formula is to be used, what are these arguments, which is number one, number two, why number two is inside the square bracket and why number one is not in the square brackets, right? So this is because it is optional, right? But number one is here, number one is not inside the square bracket because this is compulsorily required. All right. So this is how you can basically read about any particular formula, right? And you can also see what kind of inputs to be provided and what kind of output you will get, right? And an example is also demonstrated here. You can simply copy this data into the Excel sheet, right? And you can apply the formula here like this, right? So this will tell you what exactly is the implementation or the correct use of this particular formula, right? You can go through like any formula in the similar way, right? Let's say I want to look more about, let's say I want to learn about the lookup function, right? So let's say I want to learn more about VLOOKUP, right? I can simply go to the VLOOKUP here. Let's say this is the VLOOKUP function, right? I'll simply click on this. So it will take me to the official documentation of VLOOKUP. All right, so this way you can explore all the formulas in Excel. Right, so all right, guys, give me a moment. I think my screen, my Excel is hanged, right? It's not responding. All right, so this is how you can basically go for any function and have a look in detail what this formulas are, how they are to be used. All right, so let's proceed ahead with the discussions of correlation and covariance, which is part of your inferential statistics. All right, so I hope everyone is clear with the moments part. Right, you can simply raise your hands to confirm if you're able to understand the implementation, how they can be used in Excel and so on. Right, great. All right, so okay, one of you is asking, can we get the solved question and answers for statistics topic that I've shown from starting to end? So I've already shared the list of questions and I've also shared the answers, right? Please check the GitHub link that I've shared with you. I've already provided the questions along with the answers as well, right? Please check the GitHub link. You'll get the answer to your question. All right, so let's proceed. Right, so yes, of course, this is your last class on Excel and statistics, right? I believe yesterday your programming foundation has already started in your regular session timing, right? Which is 9:30 to 11:30. Right, so this is your last session on Excel and statistics. And moving ahead with this, you'll learn about SQL programming. All right. Now, moving ahead, let's discuss about the inferential statistics, which is which is skewness and this is correlation and covariance. Right, so I'll share the GitHub link towards the end of the session once again, right? Since this is your last session, so I'll share this link one more time with everyone, right? Not a problem. All right, so I'll share more questions and along with the extra data set, right? Please check your GitHub link from let's say time to time. I'll upload more questions, I'll upload more data sets, right? So that it will help you in practicing Excel. All right, so let's proceed ahead discussing about the topic of covariance. Right. So covariance is basically nothing but it is combined variance. right? Combined variance. So since the word combined is involved, which is why this will always be calculated on two variables, right? Let's say two variables or features, right? Or in layman terms, we call them as columns, right? Everywhere in, let's say, machine learning and data analysis, you'll hear these two terms, features or variables, right? All right. So this is basically combined variance on two features. All right. Now, if you recall the formula for variance, right? The formula for variance is basically summation of xi minus mu whole square by n. Let's say n minus 1, right? Now, if you break this, right? So this basically tells you about spread of a column, spread of data into any column, right? Now, if you expand this, summation will remain as it is, right? Instead of writing xi minus mu whole square, I'll write xi minus mu into xi minus mu, right? This is exactly what square means, right? Followed by n minus 1. Right. So this is exactly what square means. I am going to multiply the same number two times. Basically, I'll multiply a number with itself. Right. Now, the second thing is, let's say, since variance is calculated only on one variable, right? Which is why it's variance. And if you try to calculate variance on two variables, what can be done is you can replace one of these columns or one of these figures with some other value, right? Let's say this is for some column small x, and this value is for some column small y, right? Then it can be calculated for two columns, right? So let's say instead of xi minus mu of x, right? Mu of x is basically mean of the variable x here, right? And if I put, let's say, yi minus mu of y, if I multiply these two terms, I'm basically replacing one of these figures with another columns figures, right? Instead of taking the square, I'm multiplying the variance or distribution of two columns, right? I'll divide this by n minus 1. All right. So this is basically the formula for covariance. And this is how it's written between x and y. Right. So this is how covariance is calculated. All right. So covariance, if you see this particular formula, right, this formula can give you both, let's say, positive and negative values. All right. Now, the thing is, covariance will always tell you about the direction of relationship. Right? It will always tell you about the direction of relationship. Because since it's a relationship, right? It will directly change if the values are changing, right? But ideally, your values should not change because the relationship, how it's defined is, right? How it is defined is the relationship should not change with changing the figures or changing the elements. It should always change if the variation is taking place. For example, right? So for example, let's say if you, for example, let's say I have some figures, let's say 1, 2, 3, 4, 5. Right? This is one column, let's say this is X, right? And in Y, I have, let's say 5, 4, 3, 2, 1. All right, I have 5, 4, 3, 2, 1. So these are basically the two figures. This is not 21, this is 2, right? So these are the two figures. If I try to calculate the covariance between X and Y, I can basically, I'll end up getting a value, right? Some value. What will happen? Let's say if I double each of these values, or if I, let's say, take the square of values, right? If I, let's say, if I derive some X dash here, X dash, in which I'm simply multiplying every value with 2, right? So this will become 2, 4, 6, 8, 10. All right, and I'm deriving Y dash from Y, where I'm maybe again multiplying with 2 itself. So this becomes 10, 8, 6, 4, and 2. Like this, right? So the nature of relation is same, right? Your nature of relation should not change. Because the relationship between these two, if I multiply any number with a constant, if I'm multiplying all the numbers with a constant, the relationship should not change, right? The relationship, that's exactly what relationship is, right? But the covariance will change because it purely depends on the figures of the or values of the data, right? Which is why covariance always tells you only about the direction, right? If covariance is positive, you'll end up getting three kind of values of for covariance, right? First is you'll end up getting a positive value, you'll end up getting a negative value, and you'll end up getting 0, right? You can always get 0 as the output as well, right? So this basically says there is no covariance, no covariance, right? If you're getting a positive value, this basically says the nature of relationship is in the same direction. Same direction. What does this basically mean? Let's say if I'm increasing the values, let's say here the values are increasing in this direction, but here the values are decreasing in from right to left, right? So let's say if I increase these values, let's say the next value is 12, right? Next value is 12. So here, what will be the next value? Ideally, it should be 0, right? Ideally, it should be 0 because I'm decreasing every value by 2. I'm decreasing every value by 2. Decreasing every value by 2. So ideally, it should be 0, right? So using this value, I'll try to figure out what is the nature of this relationship, right? When I'm going from left to right in X dash, how the values are changing from left to right in Y dash, right? So this is exactly the direction, right? From left to right, values are increasing, but in Y dash, from left to right, the values are decreasing, right? So this is negative correlation, which means the values are changing in different directions. If I'm increasing value of one of these figures, it will decrease the value of other in Y dash. All right, so this is exactly what covariance is. And this can again be applied on the columns only, right? So for example, you'll apply it on features. So let's say if you try to calculate the covariance between, let's say, a salary column and let's say the age, right? For an, let's say for an, okay, let's take hike as that will be more reasonable, right? Let's take the hike column, right? So if someone has got hike, right, his salary will increase, right? The more the hike, the more the salary will increase, right? So this is a kind of positive relationship. All right, so guys, please give me a moment. right? I think my whiteboard is hanged. Give me a moment, I'll simply restart it. All right. So let's say the covariance. I hope everyone is able to see my screen. You can simply, let's say, raise your hands to confirm we're able to see my screen. All right, great. So basically, let's say if we are trying to calculate the covariance between salary and hike, right? So let's say, for example, if hike of a person is increasing, let's say not a person, but it's about the variation in the data, right? Let's say if someone's hike is getting, let's say if the order of the hike is, let's say 0, 2, then 4, maybe 10, 15. These are some of the percentages, those are mentioned in the hike column, right? If the values are increasing from left to right, what is the impact on the salary column, right? So salary is also increasing from left to right because someone who has got 0% hike does not have any increment in the salary, but someone who has got 2% or 4% or 10% hike has got an increment in the salary, right? So both of these will vary in the same direction, right? Same goes with maybe for a corporate employee. Let's say if you try to calculate the covariance between years of experience, right? Years of experience and age, right? So if someone's age is increasing, the years of experience is increasing, assuming that the person is already, like, he's continuously employed, right? And at the same time, if the years of experience is increasing, his age is also increasing. So they are both varying in the same direction. They're both varying in the same direction, which basically means if age is increasing, right, your how this will impact the years of experience, the year of experience will also increase, right? This is what covariance tells you. It will tell you about the direction, whether two variables or they're varying in the opposite direction, right? One of the examples of varying in the opposite direction could be the basically the direction of variation, let's say between demand and supply, right? If demand increases, the supply increases, right? If, let's say, the demand decreases, the supply also decreases, right? It can go the other way around as well. Let's say if supply of a particular uh, commodity increases, its price automatically decreases because it's available with everyone, right? It has created a kind of a competition in the market. At the same time, let's say if supply is less, the price will be high, right? So yes, this is how it tells you about the direction, right? And oh yes, one of you just mentioned a very good example for explaining the direction. It's the resale value of a car, right? Or resale value of, let's say, resale value, and resale value along with, maybe let's take the years since registration, right? Years since registration. Let's say if years since registration increases, for example, let's say, let's talk about a petrol vehicle. So the total number of years of registration that is allowed is 15 years, right? You can drive this vehicle, which runs on a petrol fuel, right? You can run this vehicle on road for 15 years. So let's say the year since registration basically means the year in which you have purchased the vehicle will be the 0th year and increasing, right? So let's say if you have made a purchase in 2022, right? So this is the first year that is going on, right? In 2023, your 1 year will be completed, right? So the resale value of this particular vehicle will be very high as compared to other vehicles. Maybe that's someone has purchased in 2017, right? The price of this vehicle will be very low as compared to the price of vehicle or resale value, right? the resale value of this particular vehicle will vary based on the number of years that you have already used that particular car, right? So covariance basically tells you about the direction, right? So the resale value decreases if the number of years on road increases, right? So this is the covariance that tells you about the direction, right? Now, to overcome this, right, we also need a value, right? I need quantification. Statistics is all about quantifying everything, right? If you're talking about relationships, it should be quantified, right? How much relationship, some figure I should be able to get, right? In mathematics, we always talk about quantification. Let's say if I ask you, right, if let's say I tell you that feature 1 is related to feature 2, right? Let's say if I tell you that feature 1 is related to feature 2, right? And it's also related to feature 3. So the first question is, let's say, which of these features is more related with feature 1, whether it's feature 2 or feature 3, right? Which have more strength of relationship. So you basically need to quantify, right? You need to quantify. Quantification basically means representing it in the form of a number, right? Quantification basically means representing in figures, right? Or in the form of a number, right? For those of you who are not able to understand the figures, it's basically, I want a number against it, right? For example, let's say this is 0.5 times related to this, and this is 0.8 times related to feature 3, right? So if I ask you, feature 1 is more related to which feature? So you'll clearly say that feature 3. Why? Because this we have quantified already, right? So this quantification is basically an extension of covariance, which will tell you about correlation, right? So this is correlation where we'll quantify how much a feature is related to any other feature, right? So here comes a new topic called correlation, right? Correlation basically is tell you about the strength of a relationship, right? It will tell you about the strength of relationship. Will tell you about the strength of relationship, right? And it will give you a number as output. It will give you a number as output, right? You can use this particular number in data analysis to find out which feature is more correlated to the target variable. Let's say I give you maybe right. So for example, let's say let's talk about the employee data set that we are working on. Let's say if I give you, right, let's say if I give you maybe I ask you to make prediction of salaries of the employee, right? I'll give you a use case, right? So we have so employee ID and employee name. Let's leave these two columns. Apart from this, we have gender, right? We have the designation, right? We have the department, right? We have the business unit into which any employee works. We have age of the employee, right? And then um, we have other columns as well, right? So we have country, city, joining date, ethnicity, right? Let's say we have ethnicity, right? And we have country and city as well. Let's say, right? Let's say in the analysis of the data, you found out that, or maybe if you try to analyze the relationship, I ask you to predict the salary of an employee who is male, right? Or maybe the designation is director, right? The department is maybe HR, right? The business unit is maybe the products, right? Age is 55, ethnicity is maybe he's Asian, right? Country he lives in is the US, right? And city is, let's say, Chicago. So if I ask you to, let's say, make predictions of, or make prediction of the salary of this particular employee, how you're going to make this suggestion, right? How you're going to make this prediction. So basically, you'll find the strength of relationship. Your salary column is highly correlated with which of these, right? So basically the highest correlation it will have, I'm talking about in ideal cases, right? The data set that we are using, it's a sample data set, right? It has been randomly created, right? So I'm talking about only, let's say, salary is highly dependent on the designation any employee holds, right? The designation of any employee holds, maybe someone who is an analyst and someone who is a director, right? Who will have more salary? Of course, the one who is director, right? So you have a very good strength of relationship with designation, maybe let's say age, right? Age indirectly tells you about the years of experience any employee holds, right? Others are secondary, right? Maybe if I ask you, someone who is an Asian, who should I offer more salary? Someone who is an Asian, or let's say someone who is a Caucasian, right? It hardly depends. This is purely a game of skills, right? Salary is offered purely based on skills, right? So these are basically nothing but the features, right? These are features. And based on these features, I'll be making prediction of this. So this is how analysis of the data will help you to, understand the data in a better way and finally give you relevant output, right? So this is where correlation helps you, right? So now let's see what exactly is covariance, correlation, right? And how you can basically find it out, right? So I've already mentioned this tells you about the strength of relationship and it will give you a single figure as output, right? Now, right, this will, I'll just write this one more time. This will tell you about the strength of relationship, right? Strength of relationship, or in other terms, it's also called degrees of relationship, right? How your features are related to each other, right? Here, it will give you a number as output. It will give you a number as output, and this number is nothing but this is called correlation coefficient, right? It is the correlation coefficient. All right, and everywhere we'll talk about this correlation coefficient only because correlation is a concept, right? But the figure, the number that you'll get as an output is correlation coefficient, right? And this correlation coefficient is basically represented by small r, right? So everywhere, wherever correlation coefficient is, let's say, it's addressed, right? Simply a small r, it is represented by a small r, like how mean is represented as mu, right? How mean is represented as mu. In the similar way, correlation coefficient is represented as small r. All right. And the best thing is, the range of this correlation coefficient is from -1 to +1 only, right? It is not beyond this. It is not less than -1. It is not greater than +1. You'll always find the relationship in the range of -1 to +1, right? Now, let's see. Right? Let's see how, let's say, can be calculated. Right? I'll tell you a very interesting concept behind this. Right? There are multiple formulas to calculate correlation coefficient. Right? And one of the most, let's say, mostly used formula is you simply take covariance between x and y, right? And divided by the standard deviation of x and standard deviation of y. Right? If you remember from the concepts of movement, this is nothing but we are applying standardization. We are applying standardization on covariance. Right? We are applying standardization on covariance. And hence, the output that you'll get will be in this range. Because if you remember, I told you what does standardization does, right? What will standardization do? Standardization will reduce the mean to 0, right? And standard deviation to 1. This is exactly what standardization does. Right? It will bring the mean to 0 and standard deviation to 1, which basically means standard deviation is 1, which basically means that your variance is also 1, right? Because standard deviation is nothing but square root of variance. If you take the square of 1, you'll end up getting 1, right? The variance is 1. And when the variance is 1, this basically means that the data is only distributed between -1 and +1 from 0, right? So the value of R will always lie in this range only, right? This is the standardization of covariance, because we are simply dividing it by the standard deviation of x and standard deviation of y, right? And here we are only calculating covariance of x and y. How covariance of x and y can be calculated? It's simple, right? Summation of xi minus mean of xi multiplied by yi minus mean of yi. Right? Again, nobody is going to ask you this formula, right? But again, someone can ask you about the concepts only. Let's say if someone might ask you, right? If you want to, let's say covariance is a very varied figure, which means it will change along with the values. If I double every value, if I take the square of every value, right, your covariance will change, but your correlation will not change. If initially your correlation is between, let's say -1 and +1, if it is, let's say 0.55, let's say if it is 0.55, it will remain 0.55 even if I square the values, even if I take the cube of the values, right? So your covariance will change, but your correlation will not change with data. All right, please give me a moment. All right, so I hope everyone is able to see my screen now. right? So this is this is one of the major reasons why your correlation will always lie between -1 and +1, because it is not going to change even if you take the square of every value, right? If you take the cube of every value, because eventually, if you take the cube of every value, your variance will increase, right? And once your variance increases, your standard deviation will increase. And eventually, we are dividing every value with, while calculating the correlation, we are dividing the covariance with the standard deviation itself, right? Which is why the range and the values will remain same for correlation. All right, it is not going to change along with the values, right? So for example, you have two features and there's a relationship. Let's say the correlation coefficient is 0.65, right? And let's say you're taking square of every value in both the columns. So how your covariance will increase, right? But your correlation between those two columns will remain same, right? So this is where correlation basically helps you in dealing with the data sets, in performing data analysis, and so on. All right. Now, there's another formula for correlation, which is it is n times summation of xy minus summation of x summation of y divided by square root of n times summation of x square minus summation of x whole square. Right, this is minus summation of x whole square, right, followed by square root of n times summation of y square minus summation of y whole square, right? This is another formula. If you look at this particular formula, this is nothing but this is just an extension of the same formula, right? Here, what we are doing is we are taking the product of every consecutive element, and then we are adding all of these together, finally multiplying with the total number of elements that we have, right? We'll see an example, right? We'll see how this can be implemented, right? We'll see an example. All right, so the most common method, of course, there are multiple types of correlation that can be calculated, but the most common is the Karl-Pearson correlation. Pearson's product moment correlation. Right, this is method. It is Karl-Pearson's product moment correlation method. Here we are basically what we are doing is we are basically taking product of the moments, right? Moments are the mean, variance, kurtosis, and skewness, right? We are not taking all the moments, but yes, we are taking one or the other moment, and then we are taking the product of the moments followed by this is basically a method, right? So for correlation. So this is the name of the scientist who gave this particular method, and this is commonly known as Pearson correlation. Right? Every time you'll be able, you'll be finding the Pearson correlation only. All right, and these two are the formulas that can easily be used. More or less, they will give you very similar figures, not exactly same, but yes, they'll give you very similar figures as output. Right, so let's see an example. This way you'll be able to understand this in a better way. Right, so let me take this data set. Let's say I have my X. I have my Y. right? Now here, the elements are 9 and 15. That's 5, right? 8 and 16, 7 and 14, right? 6 and 13. Then we have 5 and 11. We have 4 and 12. Right? We have 3 and 10. We have 2 and 8. Then finally we have 1 and 9. All right. All right, so these are the data points that we have. All right, now there are a few things we need for, let's say, we need to find the correlation between these two columns, right? How they are correlated. So if we see the formula, right, let's take both the formulas one by one, right? So eventually we'll be able to calculate this. Now, the first formula is, let's take the correlation, the standardization of covariance formula, right? So correlation is written as small r, right? This is nothing but covariance of x and y divided by the standard deviation of x and standard deviation of y. Now, if you remember the formula for variance, right? Or if you remember the formula for covariance between x and y, how it can be calculated? It can easily be calculated using the formula, which is summation of x minus x bar, this is mean of x, right, into y minus y bar, which is mean of y, divided by n minus 1. This is covariance. I'll calculate covariance and put this here in the numerator. Now, in the denominator, I have to calculate the standard deviation of x and y, right? So how standard deviation of x and y can be calculated? Standard deviation is nothing but it is the square root of variance. So standard deviation of x is nothing but square root of variance. And what is variance? Variance is summation of x minus x bar, which is the mean of x whole square, divided by n. Right? This is your standard deviation of x. You can take n minus 1. Right? We are considering this as samples. Same goes with y. Simply replace x with y here, and you'll be able to get this standard deviation of y. Right? So this is nothing but summation of y minus y bar whole square by n minus 1. Right? So these are all the terms I need to calculate. Now, to calculate these terms, I basically need to know the mean first, right? There are a few things I need to calculate for this. And these are the first thing that I need to calculate here is I need to calculate mean of x, right? I need to calculate mean of y. I need to calculate, let's say, x minus x bar whole square and the summation of this, right? This is this particular value here. If you see, this is this value, right? I need to know n, which is the total number of elements. I need to know the summation of y minus y bar whole square, right? So these are a few terms I need to know to let's say, calculate this. And finally, I need to know summation of x minus x bar multiplied by y minus y bar. These are the terms I need to know the value of to be able to calculate. If I know this, this particular value, I'll be able to calculate covariance. If I know summation of y minus y bar whole square, I'll be able to calculate the standard deviation of y, right? If I know x minus x bar, I'll be able to calculate the standard deviation of x. If I know y bar, I'll be able to use them in calculations of covariance here, right? In calculations of standard deviation here, right? X bar and y bar, of course, y bar I'll be able to use, right? And finally, n will help me to mention the same in the denominator, right? So these are the values I need to know to be able to calculate these covariance and standard deviation for x and y, right? So let's do this one by one. All right, so let me create columns for all of these so that it will be easy for everyone to understand, right? So summation of x and y can easily be calculated, right? After that, I can easily calculate the values as well, all right? Now, the next thing I have to calculate is x minus x bar. Every value with the mean of x. Then I'll add all of these together. I'll subtract y with the mean of y. I'll subtract all of these together. Basically, add all of these together. After this, I will have to calculate x minus x bar whole square. And then I'll add all of these together. I'll do y minus y bar whole square. I'll add all of these together. And finally, I'll calculate x minus x bar into y minus y bar. All right. So, and then I'll add all of these together. So I'll easily be able to calculate covariance and standard deviation followed by this, right? So let's proceed ahead. Calculations and find out the values. Right. So first, let us find out the mean of x and y, because the journey will start right from there only. For mean of x and y, I need to know summation of x and the total number of elements in x. Right. So let's add all of these together. Yes, blue color will do. Right. Okay. 1 plus 2 is 3. Right. 3 plus 3 is 6. Plus 4 is 10. Plus 5 is 15. Plus 6 is 21. Plus 7 is 28. Plus 8 is 36. And plus 9 is 45. Right. So the summation of x is 45. All right. Let's do the same for y. All right. Let's do the same for y. So 9 plus 8 is 17. 17 plus 10 is 20. Plus 12 is 39. Plus 11 is 50. Plus 13 is 63. Plus 14 is 73. Plus 4 is 77. Right. 77 plus 6 is 83. Right. Sorry, 93. And 93 plus 15 is 108. Right. So this is 108. Let me know if any of these calculations have been miscalculated. All right. So let's find the total number of elements. This is 1, 2, 3, 4, 5, 6, 7, 8, and 9. All right. So there are total 9 elements here. So if I want to calculate the mean of x, right? So I forgot to mention one formula, which is for the values of mean, right? So x bar can easily be calculated by summation of x by n, and y bar can be calculated by summation of y by n, right? So these are the values. Let's feed in. So total number of elements is 9, right? X bar is 45 by 9, which is 5, right? Y bar is 108 by 9, which is 12. right? This is 12. Now, once these values have been calculated, let's find x minus x bar, right? So x is 9 and x bar is 5. So 9 minus 5 is 4. Let me try to bring everything into the single screen. All right, so here, right? So 9 minus 5. 9 minus 5 is 4, right? Sorry, 8 minus 5 is 3. 7 minus 5 is 2, right? 6 minus 5 is 1. 5 minus 5 is 0. 4 minus 5 is negative 1. 3 minus 5 is negative 2, right? 2 minus 5 is negative 3. 1 minus 5 is negative 4. All right. So we don't need to calculate the summation of x minus x bar because it is not required anywhere, right? Square of these terms are of course required. So what we'll do is, once we have calculated this, we'll calculate the square of x minus x bar, right? So x minus x bar whole square, square of 4 is 16, square of 3 is 9, square of 2 is 4, 1 is 1, right? 0 is 0, negative 1 square is 1, negative 2 square is 4, negative 3 square is 9, negative 4 square is 16. These are the terms. I need to add all of these together now, right? So 16 plus 9 is 25 plus 4 is 29 plus 1 is 30, right? So 30 plus 30 is 60. This is 60. Right? So we have got x minus x bar whole square, summation of x minus x bar whole square. Right? This is 60. Let's find y minus y bar now. So y bar is 12, right? So 15 minus 12 is 3, 16 minus 12 is 4, 14 minus 12 is 2, 13 minus 12 is 1, 11 minus 12 is negative 1, 12 minus 12 is 0, 10 minus 12 is negative 2, right? And 8 minus 12 is negative 4, 9 minus 12 is negative 3. All right, so y bar is basically calculated using this formula. It is basic operation of calculating mean, right? You add all of these values of y together. These are the values of y. If you add all of these, you'll end up getting 108, right? And 108 divided by 9 is 12. Do the maths, right? Now, let's calculate the square of x minus x bar. Sorry, y minus y bar. All right, so y minus y bar, this is square of 3 is 9, square of, let's say 4 is 16, square of 2 is 4, square of 1 is 1, right? Square of negative 1 is 1, square of 0 is 0, negative 2 is 4, negative 4 is 16, and negative 3 is 9, right? Again, add all of these together. Again, I think we'll end up getting 60 only, because 9 plus 16 is 25 plus 4 is 29 plus 1 is 30, 31, 35, 35 plus, let's say 16 is, sorry, 35 plus 16 is 45 and 51, 51 plus 9 is 60. Yes, we'll end up getting 60 only. Right? Now, finally, we have to calculate x minus x bar into y minus y bar, and then we have to add these values together. Right? So I have to multiply 4 with 3 is 12. 3 with 4, again 12. 2 with 2 is 4. 1 into 1 is 1. 0 into negative 1 is 0. Negative 1 into 0 is 0. Negative 2 into negative 2 is positive 4. Negative 3 into negative 4 is positive 12. And negative 3 is again positive 12. Right? So 12 plus 12 is 24, plus 4 is 28, 29. 29 plus 4 is 33. 33 plus 12 is 45. 45 plus 12 is 57. Right? So this is 57. Right? Let me do this. Okay. So yes, this is correct, right? So we are getting 57. Now we have got all these values. Let's apply them into the formula. Let's calculate the standard deviation first, right? So let's calculate the standard deviation of x. Standard deviation of x is nothing but square root of summation of x minus x bar whole square is 60 divided by n minus 1 is 9 minus 1 is 8, right? So if you divide 60 by 8, you'll end up getting 7.5, right? And that too, you have to take the square root of this value, right? So 2 2 is 4 and 3 3 is 9. This will be around 2.6, right? Let me check. Let's say if I take square root, right? So this is 2.73 to be very precise. This is 2.73, right? This is summation of x. We have got one value, right? Let's do the same for summation of y. This also will end up getting the same value because the value of summation of y minus y bar is exactly same as 60, right? The denominator is also same. Hence, summation of y will also be 2.73, right? So we have got summation of x and summation of y. This is completed. Let's calculate the covariance now. So the covariance between x and y is summation of x minus x bar into y minus y bar is 57, right? And divided by n minus 1, again this is 8. All right, guys, please give me a moment. I think it's again and right. I hope everyone is able to see my screen. Right. So let's proceed ahead with the discussions. Right. So the summation, the standard deviation of y will also remain same. right? Because the values in the numerator and denominator are exactly same, which is why this will also be 2.73, right? Let's proceed ahead with calculating the covariance now. The covariance between X and Y can easily be calculated using this formula, right? And here in the numerator, it's summation of X minus X bar into Y minus Y bar, which is nothing but 57 divided by N minus 1. Again, this is 8, right? So if you divide 57 by 8, it's 8 is 56, it's 56.3. Sorry, it's 6.1, right? This is 7.6, 7.125, right? 7.125. All right, so this is the covariance. Now, finally, since we have everything, all right, so this is the covariance that we have calculated between X and Y, right? And finally, we can calculate the correlation, right? Correlation is nothing but you can easily calculate by simply dividing the covariance, which is 125, divided by 2.73 into 2.73. Right, this is 2.73 into 2.73. If you, let's say, do the maths, this is, right, so this is 0.956. This is the correlation that we are getting, 0.956. All right, so so this basically, okay, one of you is asking, what does this value indicate, right? This value indicates the strength of relationship between X and Y, how they are varying, right? The correlation between X and Y, we have found out to be 0.956. This is telling us about the strength of relationship between X and Y, right? This is very strong relationship. Right? This is very strong relationship. Even if, see, even if we have got this value in negative, that also indicates a very strong relationship, right? But the only negative and positive sign indicates the direction of relationship. All right. All right. So the values which are closer to the boundary values are, of course, they have more strong relationship there. Let me just give you an idea. Let's say this is 0. In this number line, we are basically representing correlation, right? So we have a few thresholds, which is 0.2 and negative of 0. Right? Then we have 0.8. Then we have negative of 0.8. And finally, we have negative 1 and positive 1. Right? So if you're, let's say, if the value of R lies in this range, which is negative of 0.2 to 0.2, right? If it is in this range, 0 to, this is mild relationship. right? Mild correlation. You can say this is mild correlation, right? If it is between 0 to 0.2, this is mild positive correlation. If it is from negative 0.2 to 0, it is mild negative correlation, right? If it falls into this window, 0.2 to 0.8, this is moderate positive correlation. Moderate positive correlation. If it falls into this window, negative of 0.8 to negative of 0.2, right? This is moderate negative correlation, right? If it falls into this window, this is strong positive correlation between 0.8 and 1, right? If it at the same time it falls between negative of 1 to negative of 0.8, this is strong negative correlation. All right. So this is how your complete correlation is divided, right? And this is how direction negative sign or positive sign only tells you about the direction. All right. Now let's see the same in our Excel sheet, right? Let's see the same implementation of this in Excel sheet. Here I'll just make this note that the value of R that we are getting between X and Y is 0.956. Right now, let's create a new sheet, right? So the R that we got 0.956, right? So let's see what relationship are we getting here, right? So let's say this is my X and this is my Y. I hope everyone is able to see. Let me increase the size. All right, so X will basically carry, this is 9, right? So this is 987,654, right? 3, 2, 1. Right, so this is my X, and about my Y, this is 15, right? This is 16, 14, 13, 11, 12, 10, 8, and 9. Okay, these are my X and Y. Right, so these are my X and Y. Let's find the correlation. Correlation can easily be found out using the CORREL function, right? It returns you the correlation coefficient between two data. This I have to pass array 1. Array 1 is basically my X. So this is my first array. I have to pass array 2 now. This is my second array, right? Let's execute this. I'm getting 0.95, right? So this is more or less the same value that we are getting. If let's say if we increase this to more number of decimal places, right? This is 0.950. All right. So this is the value that we are getting, and this is the exact value using the formulas, right? So it is same up to second place of decimal, right? So yes, this is how correlation can be found out. In the similar way, you can find covariance as well. Let's say you can directly find the covariance for samples. All right. Here I need array 1. So this is my first array. And I need array 2. This is my second array. If I execute this, I'm getting 7.125. I think this is exactly what we got in our manual calculations. Right? Let me see. Yes, this is exactly what we got, which is 7.125. right? Correlation. If you divide it by, let's say if you calculate it for samples, your correlation will remain same because correlation does not change, right? So your correlation will remain same. Let's say this will be my first array and this is my second array, right? So my correlation will be same. This is for sample, right? And this is for population, right? And my covariance for population, right? So this is my first array and this is my second array. To calculate this is 6.33. So basically, this is the only differences of the denominator. In one, we are calculating, we are dividing it by n, and in samples, we are dividing it by n minus 1. Right? So this is the only difference. All right. So yes, guys, this is how you can easily find the correlation. Let's say, for example, let's see the same in our Excel sheet. All right. So let's say if I want to find the correlation between age and salary column, let's find it here, maybe here, right? Correlation between age and salary. We'll simply use the correlation function. First array will be the age column, right? And my second array will be my salary column. Let's find the correlation. It's negative of 0.023666, right? So this basically means if the age is increasing, the salary is not increasing, it's decreasing, right? So this is just because this is the manual data, right? It is not the actual data of an organization. This is a sample data set that has been created, which is why we are getting these random values. Right. So what conclusion you will get if the relation is strong? So basically, if the correlation is strong, it will hugely impact, right? Change in one, I'm sure every one of you at some stage in life, you have heard about the terms which is directly proportional, right? And inversely proportional. Right. So for example, let's say here, since we are getting a positive correlation, this basically means my X is directly proportional to Y, right? And for age and salary column, we got a negative correlation, right? So this basically says my age, or let's say my salary, is inversely proportional to age, which basically means if my age is increasing, right, my salary is decreasing, right? Or vice versa. If my salary is increasing, my age is decreasing, right? This is the insight information that is being provided by correlation. This is correlation insights, right? And here it says if my X is increasing, my Y is also increasing. And if my X is decreasing, my Y is also decreasing. All right, so this is the information or the insight that you'll take from correlation. And this will help you hugely when you'll use this concept in machine learning. Because in machine learning, one of your variable here will be a variable that you're trying to predict. This is called target variable, right? This target that you're trying to predict, right? So for example, how I told you that, let's say based on all these features, you need to predict the salary of an employee, right? So basically salary becomes your target variable, right? So these values are not given. You have to make prediction of these values, or you have to basically predict these values based on your analysis on the data, right? Or based on your machine learning model that you have trained. So the concept of correlation will help you to understand which feature is contributing more. Maybe let's say, although there is no direct relationship, right? But you will easily be able to find correlation between ethnicity and maybe the salary column. Maybe people who belongs to black ethnicity, they're gaining very high salary, right? And maybe let's say people from Asian ethnicity, they are getting low salary as compared to black ethnicity people, right? Or maybe someone who has joined very early in this organization is getting very high salary, and someone who has joined late is getting very low salary, even if both of them hold the same designation in the same department, they belong to the same country, lives in the same city, right? Then also you'll see that maybe someone has got more, someone is drawing more salary and someone is drawing less salary. This purely depends on the correlation, right? So there's something called as correlation matrix that will be built on top of correlation, right? So how this will be built is, let me give you this idea, all right? So basically there will be a correlation matrix that will be built, right? So for example, let's say instead of three, you have, let's say instead of two, you have three columns, maybe X, Y, and Z. You have some values here. All right. So correlation can be calculated like this, or the correlation matrix will be built like this. Right. And how this will be built is basically you'll have the correlation. All right. So you'll have this correlation coefficient since there are three columns, right? So there will be three rows, first row, second row, and third row. And there will be three columns, 1, 2, and 3. So this will be a 3 by 3 matrix. And what values these 3 by 3 matrix will hold, right? The values these 3 by 3 matrix will hold will be here, the correlation between X and Y. Here you'll have correlation between X, correlation between X and Y. Okay. Sorry, here you'll have correlation between X and X. Here you'll have correlation between X and Y. Here you'll have correlation between X and Z, right? In the next, there's the first row. Now the second row, you'll have correlation between Y and X. You'll have correlation between Y and Y, and the correlation between Y and Z, right? In the next row, you'll have correlation between Z and X. You'll have correlation between Z and Y. You'll have correlation between Z and Z. Right. So this is how your 3 by 3 matrix will be constructed. And if you have 10 columns, let's say, for example, if you have 10 columns, if you are working on a data set that has 10 columns, for example, let's say the employee data set we are working on has 14 columns, right? So this matrix will be 14 by 14 matrix, right? And this will be symmetric matrix through diagonal. All these values will be 1, right? Because correlation between correlation of a column with itself is always 1, right? If you try to find correlation between X and X, right? X and X, this will be 1. And the same will be equivalent to for Y and Y, Z and Z, right? You can do the maths, you can use the maybe the formula of Excel, right? To find the correlation between X and X, Y and Y, Z and Z, getting 1, right? Because it is perfectly positive correlation, right? And this is symmetric, which means the correlation between X and Y, correlation between X and Y is equal to correlation between Y and X, right? Correlation between X and Y is equals to correlation between Y and X. You take any matrix first and take any array first and any array later, it does not matter, right? Same goes with correlation of X and Z will be equal to correlation of Z and X, and correlation of Z and Y will be equals to correlation of Y and Z, right? So this way, once you're able to plot the complete correlation matrix, there's a single function to plot this matrix in pandas, right? In pandas, we have a single function. This is a library of Python. You'll learn about this library, right? So this is basic, correlation will help you to in the data analysis. All right. So yes, guys, with this, we are wrapping up the session for today, and my part of Excel and statistics is over in today's session. Right. So let's say if you have anyone of you have any doubts, maybe I'm waiting for 10-15 minutes extra. If you have any doubts, you're free to ask in the chat section. Right? Otherwise, those who are leaving, I wish every one of you all the best for your, let's say, further learning phase. All right. So, any one of you, if you have any doubts, I'm waiting. You can simply share your doubts. I'll be answering them one by one. Right. And I'm sharing this GitHub link with everyone. Those who have not taken it, you can simply bookmark this link. Right. So any doubts in future, please raise a ticket for excellent statistics. Right. The team will address your query over the ticket only. Right. Okay. One of you is asking how correlation can be performed upon salary and ethnicity, since ethnicity is not a number. So basically, your machine, when you'll do the machine learning, in between, you'll learn something about a topic called encoding, where we'll encode the categorical data into numerical representations. Right. So this part will basically transform your categorical features into numerical features. Right? Because your machine, any machine, your system, right? The laptop that you're using, your CPU only understands numbers. It does not understand any form of text, right? So which is why you always have to pass the data in the form of numbers, and to transform categorical data into numbers, there's a process called encoding. You'll learn about this in your machine learning phase. Online practice of Excel can be done on Medium. You cannot do it on Medium. Medium is basically a blog-based platform. You can learn more concepts of Excel on Medium, right? You cannot practice on Medium. Right, so I'll upload additional data sets and problem statements. All right, so basically, you can increase the learning on Medium, right? You will not be able to solve questions on Medium. Are there any books for Excel and statistics? I believe for statistics, I've already, gave you the name of the book. The name of the book is Think Stats, right? It is one complete case study. The complete book is one single case study. So it is advised to go through that so that you get an idea of the concept along with the implementation of that concept, like what is the exact use of that particular concept in the field of data analytics, right? So Think Stats is a very interesting book that you'll easily find on platforms like Amazon, right? Okay, in Excel, why are we getting learn through table? I did not get this query. Can you please repost your query, reframe it? Yes, I'll be adding more exercises on the same GitHub link. All right, and I'll try to provide some of the. I'll try to provide some, some some worksheet that will eventually help you to do data analysis. I'll include the questions as well into the data sets. Right, so everything has to be done on applications, right? No, nothing has to be done on pen and paper. right? You have to implement all of the concepts on one or the other applications, right? The machine learning that you're going to learn, right? That machine learning can also be implemented on Microsoft Excel, right? So let me show you a few algorithms. Those are part of your statistics only, right? So if you're able to see, right, when you go inside the statistical functions here, simply go to the formulas, right? You go to more functions, and then you go to statistical functions, right? There are like formulas that can easily be applied, right? Which is part of your machine learning algorithm as well. These formulas are, let's say, you have linear regression, right? Regression that simply go through this, you'll get. Right. So the question, to answer to the questions that I gave you as a part of your homework, I'll upload. I have already uploaded the solution. Only one part of the solution is not uploaded, which is this particular sheet. I believe this part of the question is not uploaded. I'll resolve this particular question, right? I'll upload the solutions for this as well on the same GitHub link. All right. And moving on with the interview questions on Excel and statistics, you'll get you will combinedly get the interview questions towards the end of your learning phase, right? When your pre-placement phase will start, the first thing that we are going to do is we are going to walk you through the interview questions that can be asked on various topics, right? So we'll simply walk you through all at once. Right, so percentile topic is also necessary. Yes, percentile is one of the most important topics in statistics. Right, so I believe I've already shared the GitHub link. So is packet publishing good for data science books? So see, the best data science books are from the O'Reilly publications, right? They offer the best data science books, not only data science books, but yes, other books as well. Like if you're interested in big data, NLP, deep learning, right? Any let's say any field related to technology, they provide really good books on every single individual topics, right? Cloud computing or anything. Right. So whether you're going to have any exam assessment or something like that on Excel, you please connect with your career coach team for that. They'll be able to guide you, um, through the curriculum. All right. So this is your last Excel and statistics session, right? And moving forward, your batch has already started, attending the programming foundation module, right? From yesterday itself. So today also you're going to have your regular session on programming foundation. Moving ahead with this, you'll learn about SQL, and after that, your Python will start. All right. So if any one of you have any further queries, you're free to connect with the technical team over chats and tickets, right? The team will help you. And in case, you are facing any difficulties, do drop your exact difficulty that you're facing, right? Simply mention the exact problem you're facing, and then the team will precisely address your query. All right, so advanced Excel is part of your electives, right? So you get in touch with the career coach team to get to know more about advanced Excel sessions, right? Advanced Excel is part of your electives. All right. So until when your let's say until when your live sessions will be conducted, and for all these things, simply connect with your career coach team, right? So I've shared the GitHub link one more time. Those of you who might have missed it by any chance, you are free to take this link and save it somewhere, right? All right, guys. So with this note, we are wrapping up the session for today. And thank you everyone for joining this session. And I wish every one of you all the best for your future learning phase. All right. So yes, thank you, guys.